Hi guys, in a previous video we looked at taking some user input and doing some sort of arithmetic on that, and we looked at one possible pitfall to do with dividing by zero and how that can crash your program. The way we handled it there was to check the user input against to confirm essentially that it wasn't zero, so that we knew we would probably be safe to divide by that number. So in today's video, we're going to look at another way, a sort of more generalized way that you can handle any type of error. And let's look at that now. So open Visual Studio. We'll create new project. We want .NET Framework, C# console app, as always. And we'll call this one error catching, because that's what we'll be doing. I'll click create. So we're going to make a program that crashes now. So let's just outline what we plan to do. So we will run some code that will crash the app. We will try and display a message, and then we will wait for the user to hit return before exiting. So, spell mistake there. So we know that dividing by zero crashes the app, so let's just do that. So let's just say var crash equals 10 divided by zero. Now, actually, I believe it'll stop me from doing that. So yeah, it's smart enough to know that I'm trying to divide by zero on purpose. So what I will do is I'll make a variable called zero and set it to zero, and then we will divide by that, because I know it's not smart enough to detect that that is an obvious attempt to crash it on purpose. We'll try and display a message. So let's say console.writeLine, you survived the divide by zero. Well done. So if we make it this far, we've obviously survived this attempt to crash the computer. And then finally, we will do our old friend console.readline to stop the program from quitting. And now if we run this, you can probably guess what happens. We tried to divide by zero and our program crashed. So the way we dealt with this before was we would check to see if zero, or whatever number we're dealing with, in the previous example it was user input, was equal to zero, and if it wasn't, then we would skip this line entirely. But there is actually something else you can do which works not only for dividing by zero errors, but for any type of error, and that's called a try catch. So if I type in try and then open some braces and catch and open some braces, what we can do here, I mean, you probably tell this looks a little bit like the way we declare an if statement, except we haven't got any conditions in here. So we can put some code in that try part that we think might crash. Now, we know it'll crash in this instance, but in a real program, you might have some code that is causing you some trouble, or there's like, there might be hundreds of different ways that a user could crash your program through a particular piece of code, and you don't want to have to put in conditional logic to fight them all off. You still probably should do that, but let's just say you want an easy way to catch that error and handle it in a way which doesn't crash your app. So that's what try catch can do for you. So we can try some code. If the crash actually happens, it'll catch us in here without crashing the program, and then this block of code will run. So let's see what would make an interesting program. We know this is going to crash. Let's just put a message out to the screen here, console.writeLine, and we will say program was saved by the catch block. So now if we run the program, we will try and divide by zero, and then we will get this message to let us know that we've hit the catch block, because this obviously crashed, and then the program will continue as normal. So let's look at that. So you see here, the program was saved by the catch. You survived the divide by zero, and then on user input, the program will just end. And there we go. So that's another way that you can catch any type of error. There's a little bit more you can do with that, so stick around if you want to see what I might do in a real world scenario. You can actually add a parentheses on the end of this catch block, and can actually be called like a function. So you can say it's a function that takes an error, and an error is also an object. So in .NET we have this object type called system.exception. And in here, we can actually find out what type of error it was that crashed our program. So instead of, in addition to putting that line in there, we'll actually put another one in. So we'll do another console.write line, except this time we'll pull some information out of the error. And we can say error dot, and there's a number of functions and properties in here that we can look at. So we can look at message, and this is a message that describes the current exception. So the exception is just another word for error. So that'll describe the error that caused the crash. The stack trace is actually sort of a list of functions and objects that were being used up until the point that your program crashed. So that can be handy if you're not really sure where a crash is coming from. So it could be happening inside a function, inside a function, inside a function, and it can go on. Big complex programs can get quite confusing like that. The stack trace is really good for diagnosing those types of issues. And then inner exception is kind of like another exception inside this exception. I won't go too much into that because that can be a bit confusing. But what we want to do is we just want to put the error message in our console app so we can tell the user exactly why the program crashed. And in the real world, what you might actually do is write this out to a log file. So if you've got a user that says, oh, it keeps crashing, or I keep getting this error message come up, because you're catching the error and the program doesn't crash, but maybe it tells the user, hey, actually something's gone wrong, and I've put something in the log. And then you can have that user send you the log, and then you can put things like the error message that caused the crash in the log, so you can try and diagnose it even if you're not on the machine that's actually crashing. So let's have a look at that. Let's run that. So you see here, we were saved by the catch block, and the error message was that we attempted to divide by 0, and then obviously we get our final message that we survived, well done, and then we just close the program. So that's catching errors. One thing you might be tempted to do, especially when you're writing buggy code, as you probably will be as a new developer, is to just wrap every function, all of the code in every function inside a try catch, and hope for the best. And that will get you quite far, to be honest, but it's not the best way to do stuff. But if you know for sure that say a block of code keeps crashing whilst you're developing, and you're not really sure exactly what sort of user input or what input in general has caused that, these are really useful for catching it and then saving some information about it to a log. So just try and bear that in mind.